Hi everybody, welcome to video notes 61A and B. We're talking about moles. So we got to be able to count stuff while weighing it, and we have to be able to change. We have to know molar mass, change mass into moles, and change moles into mass. So we got to talk about what that means. We're going to use a technique called dimensional analysis. We're going to use conversion factors, which are qualities that are used to cancel out and get to units. So an example is that's the wrong color. 1 dozen things equals 1 dozen equals 12 things. This is a conversion factor because it's equal. 1 dozen equals 12 things. That's an equality. And then we could say 1 dozen over 12 things if we want to cancel out things and change it to dozens, or we can say 12 things equals 1 dozen if we want to cancel out dozens and change it to things. Okay, so the units are going to guide you, and you're going to always set up an equality, turn it into a conversion factor so that what you're trying to get rid of goes on the bottom, what you're trying to change it to goes on the top. So cancel what you want to get rid of and change it what you want to get to. Okay, so you got to put the correct number with the correct unit so that it works out the way you want. So let's practice. 1 dozen equals 12 things. We already did that one. Okay. 1 liter equals 1,000 milliliters. Now, we talked about that a while ago, but we're going to be using it. We can use it again now. Okay. So what we do is if we are given, so this is what we're given, and what we're trying to find or solve for is liters. So given milliliters, find liters. So we have to change milliliters into liters. We know that 1 liter equals 1,000 milliliters. That's an equality. That's a equality statement. Okay. So we start with the given 212.3 milliliters, and we want to change it. So we're going to multiply by what's called a conversion factor. The unit of milliliters has to cancel out. The unit of liters is what we're trying to find. And then we use the numbers that go with in the right spots. So 1,000 goes with milliliters, 1 goes with liters. And then to do the math, look, milliliters cancel, we're left with liters. We do 212.3, and it's really times 1 divided by 1,000, but we really just do 212.3 divided by 1,000, so we get 0.2123 liters. So 212.3 milliliters equals 0.2123 liters. Okay, here's another conversion thing that includes things you might know that are equalities as well. So we're given 88 school days. We want to find minutes. How many minutes until summer vacation? Okay, so we know that 1 day has 24 hours. Okay, we also know that 1 hour has 60 minutes. So these are equalities, and we're going to use them as conversion factors. So we'll start with our given 88 days, and we're going to cancel out days by putting it on the bottom so that it cancels out and changes to hours. And then we're going to do another conversion where we cancel out hours and change it to minutes. Now we have to make these true conversion factors. So we use, so for every 1 day, there's 24 hours. All right, minutes and hours. For every 1 hour, there's 60 minutes. So if we convert that, what we'll end up doing is doing 88 times 24 times 60 gives us, 126,720 minutes. Okay, so look at that. Days cancel days, hours cancel hours because they're in opposite spots. We're left with minutes, and that's a lot of minutes, but it's only 88 days. Okay, now we're going to take this to chemistry level by talking about the smallest pieces in chemistry, and right now it's particles. We've been using circles or other symbols for particles. Particles are too small to see or count, so we're going to count them by weighing them. And the law of conservation of mass says that particles can't be created or destroyed, so we can count with mass before reaction and after reaction, and the mass should be the same because the number of particles doesn't change. One type of particles are called atoms. There are other types of particles, like combinations of atoms, can be called molecules, etc. Okay, particles in chemistry are really, really small. In fact, if we wanted to count the atoms in a cell, in one individual cell, which is hard to see even with a microscope, this is how many atoms are in a cell. That's a ton, right? If we wanted to count the particles and grains of salt, there'd be this many. Now you can even count that high. So let's talk about other ways we group things together. So in Indiana, I could buy a ream of paper, a gross of bottle rockets, and a dozen donuts. Why do I need such large groups of numbers? It's because it's easier. There's a lot. There's small things. Okay. In chemistry, you use a mole. So what is a mole? It's this many things. 6.02 times 10 to the 23rd. Why so many? Because they're really, 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 really tiny. All right. So a mole is something to help us count, but we're going to count by weighing. This number is also called Avogadro's number, 6.02 times 10 to the 23rd. Okay. What does that represent? Number of things. So a ream, a gross, a dozen, and then a mole. Okay. So when we talk about these, we want to know how many they are. Well, a ream, a gross, a dozen, and a mole are this many things. In a ream, there are 500 things. In a gross, there are 144 things. In a dozen, there's 12 things. In a mole, there's 6.02 times 10 to the 23rd things. Okay. So how can I count by weight? Well, if one piece of paper weighs 1.77 grams, how much would a ream of paper weigh? Well, since a ream is 500 things, okay, and the things here are paper, I want to know how much it weighs. We know that one piece weighs 1.77 grams, okay? So if we have 500 things, 500 pieces of paper, okay, and we know that one piece of paper weighs 1.77 grams, then we find out that 500 pieces of paper would weigh 885 grams. Okay, so do we have to count out 500 pieces of paper? No, we could just weigh paper until we have 885 grams, and then we know we have 500. Okay, so a mole. How is a mole related? So this is a little but furry mole, cute, and this is moltato because look, it looks like a mole. So there's its mouth, there's its eye, and look, here's its little hands. Ooh, look at its little hands. I'm a mole. I'm a moltato. Anyway, a mole is a unit of measure in chemistry, and we're going to count out how many particles we have by weighing them. Now, on the periodic table, usually under the symbol of an element is how much a mole of that stuff weighs. So 1 mole of aluminum weighs 26.982 grams from the periodic table. Okay, so let me go. All right, so mass is going to be measured in grams. Right? So, so this is how much 1 mole of carbon weighs. That's how much 1 mole of nitrogen weighs. That's how much 1 mole of oxygen weighs. Okay, so we got to go to the periodic table to get the grams to figure out how much 1 mole is. Now, this is not me saying don't do it. This is me saying what if we have the particle NO, which is nitrogen monoxide. How much does it weigh? Well, we'd go to the periodic table and we'd find 14.01 for the nitrogen, 16.00, and you might be saying to yourself, but it says 15.99. We're going to round up to 2 decimal places, so this is going to be 16.00. And so then you add it together, so then 1 mole of nitrogen monoxide is going to weigh 30.01 grams of nitrogen monoxide. So here's an equality that we could have. That's how much 1 mole of that weighs. Okay. What if we had carbon dioxide? All right. So we look on the periodic table, we get 12.01 for carbon, 16.00 for oxygen, but there's 2 oxygen in this molecule. So then we have 32 plus 12.01. So 1 mole of carbon dioxide weighs 44.01 grams. Okay, so the mass from the periodic table is 1 mole of that substance. If we have a compound, which is a molecule of that substance, how much would 1 mole of that compound weigh? You got to add up the masses from the periodic table. Okay, here's a couple more. If we want to know about mass in moles, you got to go to the periodic table. So this is called aluminum hydroxide. It's got the element aluminum, the element oxygen, and the element hydrogen, which from the periodic table is 1.01. Okay, so aluminum is 26.98. And since there's only 1 in there, I only need it once. Oxygen has 3, so we have 16.00 times 3 plus And then hydrogen is 1.01, and it's also times 3. Okay, so if I add all of this together, we have, find out that 1 mole of aluminum hydroxide is going to have a molar mass of 78.01 grams of aluminum hydroxide. So all I did was take 3, so this is 3.03, the 16 times 3, so that was 48, plus, and that gives us 78.01. All right, for this one, you get 14.01 for nitrogen, 1.01 for hydrogen, but there's 4 of them, so you have to multiply by 4, and then chlorine is 35.45, all right, which isn't on here, but it's on the periodic table, okay? Well, this is only part of the periodic table. So anyway, we add all that together and we find out that 1 mole of ammonium chloride has a mass of 53.50 grams of ammonium chloride. Okay, so where does this number come from? Well, anytime it's moles and grams, you got to go to the periodic table to get it, and you have to add up all the stuff in it. Okay. All right. So in chemistry, we count by weighing. So the molar mass is anything is the mass of 1 mole. Molar mass, 1 mole of the substance. Okay, so 1 mole has the same number of particles as a mole of something else. So we must remember that 1 mole is equal to the mass in grams from the periodic table. From the periodic table. All right, so 1 mole is equal to mass in grams from the periodic table. Keep that in mind. All right. So let's start converting. We are trying to find grams if we are given moles. And this time it's iron, the element iron. Okay, so we would say, well, I'm given 0.32 moles. Look, that's an M. Moles of Fe. Now you have to put the unit and the identity of the substance. And we want to change it to grams. So the unit I have to put on the bottom is moles, because I want it to go away, and the unit I want to get to is grams, so I put it on top. Okay, so then if I went to the periodic table, I'd find that 1 mole of Fe equals, and I have to look for iron, I find 55.85 grams Fe. So this is an equality. It's the molar mass of iron, so now I put the 1 with moles and the 55.85 with grams, and then I do moles cancel moles, and I'm left with grams, and then I do 0.32 times 55.85, and I find out that I have 17.87 grams of iron. Okay. This time I want to find moles, okay, given grams, all right, and it's hydrogen gas. So from the periodic table, I find out that 1 mole of H2 equals 2.02 grams of H2. Now, hydrogen is 1.01, but H2 means I have to multiply it by 2, so it's 2.02. So now I start with the given, 43.8 grams of H2, and I multiply by a conversion factor, which is an equality. Grams go on the bottom, why? Because I want to cancel from the one before. Moles go on top, why? Because it's what I'm trying to get to. Number 1 goes with moles, and 2.02 goes with grams, and I find out that there's 21.7 moles of H2. Okay? All right, more conversions. How many grams would, okay, so find grams, and then given moles. So I know that 1 mole of CO2 weighs 44.01 grams of CO2. Now I did that from before. Carbon dioxide is CO2. So I want to change 3.25 moles of carbon dioxide and change it to grams. So I have to put moles on the bottom because I want to get rid of it, grams on the top because I want to get to it. And 1 goes with moles, 44.01 goes with grams, and I find out grams of CO2. Now I'm going to leave that one for you to fill in, okay? A scientist needs 586.39 grams of iron 3 oxide. So this is, how many moles is this? So find moles given grams. All right, now You wouldn't know this, so I'm going to tell you iron 3 oxide is Fe2O3. All right, so I want you to figure this one out. All right, I want you to look at the periodic table, find iron. Okay. I'll tell you that, so iron, I'm doing this one right now. And so, okay, so I'm just going to write this down. You see if you get it. And then we have to change grams into moles. And I know, you're like, do you hear the buttons of the calculator? All right, see if you can get this answer. 3.67 moles of Fe2O3. So you try it, okay? See if you can show this work. So I want you to get this answer, all right? And I want you to show work to get that answer. Okay, so to review, moles are groups of particles that contain this many particles. This many, that's a lot, okay? Molar mass is the mass of 1 mole, so you got to go to the periodic table to get grams. Always go to moles, or go through moles. 1 is the number that goes with moles when the other unit is grams. Conversion factors help us solve problems, and we can count by weighing. So here are the objectives. Remember, you're going to see these on the unit summative, all right? The celebration of learning, okay, for 6A and 6B, so see if you can do it. All right, have a good one. Peace out.